Hi everyone. Hello Samir and Bob, can you hear me?
Yeah.
Okay. My name is Shiv. I'll be working with you on this course, and today's session I will walk you through what we are going to cover and how uh, how will how will be taking care of all the topics. Before that, if you can give a quick introduction about you, what is your expectation from course, then it will be helpful for me. So maybe Samir, you can say what you want from this course and what is your background, then it will be nice.
You're asking me?
Yeah.
I want to learn JBoss Fuse ESP and using Camel routines, how to deploy a project. So
Okay.
that's what stuff I'm looking for.
And you have worked in Java previously?
Yeah.
And okay, and you are aware of Spring?
Sorry?
Are you aware of Spring?
Yeah, I know Spring. Yeah.
Okay, that's good. Have you worked in any ESB earlier?
Yeah, I know. UDSP.
Okay, so you are aware of the concepts. Okay, that's good. Bob?
Yeah, I know Mule, but I don't really know anything else.
Okay. Fine. So basically, JBoss Fuse is a enterprise service bus. It is from Red Hat. Before Fuse, there was another company called Progress. They used to provide another enterprise service bus called Progress, Progress Fuse, and this company was acquired by Red Hat sometime back. And Red Hat had its own application server called has Red Hat JBoss. So they kind of merged the Progress Fuse and Red Hat and created a new ESP, which is the Red Hat JBoss Fuse ESP. Being an enterprise service bus, it is based on multiple open source stack, and they follow Apache 2.0 licensing. So their model is not that you buy the license for it, you buy the subscription for it, and based on the level of subscription, you get support. So you don't buy the license, you buy the subscription, and based on that, you get the support from the user. So it is based on open source, and it is using multiple open source technologies for doing various aspects of the enterprise service bus. So for the routing and mediation, they are using Apache Camel. Apache Camel is integration framework. So Apache Camel is not the ESP; it is the integration framework, which basically takes care of routing and mediation. We'll discuss what is routing and mediation. And then in any good ESP, there should be also built-in support for message brokers. So Fuse is using ActiveMQ, Apache ActiveMQ as the message broker. That is the default message broker of Fuse. And it has support of Apache CXF for web services, and it has support of Spring for IOC, DI. Even you can write your integration logic in Spring. And it has other third-party libraries which you need for some integration aspect. So you may have worked on other application servers like Tomcat or JBoss. Those are J2E servers, Java 2 Enterprise Edition servers. JBoss Fuse is not complete J2E server. It is based on Java. It needs Java to run, but it is based on a new modular concept in Java called OSGI. So it is a OSGI container. So what is OSGI is, we all know there's a modularity concept in Java, and we write packages and to divide our work into multiple packages, and then we use packages in each other. One package can be used in another class and all. OSJ is a concept where which has taken modularity to a kind of next level, where we say that apart from using the packages, I should also tell my dependencies, and I should also express my services in a more exclusive way. You just don't use the other package. You have to say very clearly that these are my dependencies. So it's a way of declaring the dependencies and declaring the services, and then the deployment model changes a little bit based on this concept. So we'll go over the course in detail about these concepts. But for a short discussion, it's a deployment model, and it's a modularity concept through which you can define the dependencies of your application, and at the same time you can also define the services offered by your module. So these are the two things important in OSJ. So Fuse is using this model of deployment. So you need to, once you create an application, you will need some dependency to run this application. Let's say you have a database application. So you will need some dependencies to connect to a database, or if you are using any transaction, or if you are using any other application libraries, then you will need all those dependencies. So you will be declaring them before using them, and then if your module is providing some service to other modules, you will also expose them. So both the ways we'll be doing. So in order to run this kind of model, we need to have a runtime container which will support this deployment model, or which will support this modular model. So there is a OSJ, as I said, is a specification where they say how to declare the dependencies. Similarly, these specifications have been implemented by some vendors that provide some containers to run this. So Apache Carrot is the runtime container of Fuse. Basically, it's the OSGI container where internally we deploy our applications in Fuse. So if you take Fuse as a USB, it will give you routing and mediation engine. It will give you a broker. It will give you support for web services. It will give you support for Spring. It will give you a runtime container which is based on OSGI. It will give you other third-party libraries, and it will also give you an administration aspect. So using the administration aspect, we can do the monitoring, troubleshooting, live debugging, management of our applications, doing some orchestration like starting, stopping, restarting, updating applications. All those things we can do. So all those things in a package is provided by Fuse. So during the course, we'll go through the installation, configuration, and how to run Fuse, and then we'll see how to deploy the application, how to manage them, how to see the logs, how to start stop application, how to ensure dependencies of my application are resolved, and if you face any issue in the dependency resolution, how to fix that. Okay. And second aspect, yes.
Your voice is echoing actually, so.
Why should it echo? I'm using headset. It should not echo ideally.
Yeah, because I'm hearing your voice 2 times at a time. So.
What is your end problem? Not his end. Can you
Okay.
reduce? I'm getting good voice only. Babu, you are getting?
Yeah, your voice is echoing.
Are you using headset or just on the speaker?
Yeah, we can comprehend.
Yeah.
We
Yeah.
understand what you're talking, but there's an echo and there's some noise.
Yeah, I mean, I'm using headset, so.
Okay. Okay, let's see what it is happening.
Mm-hmm.
Anyway, maybe some audio setting in either side. Okay. Then on the Camel part, which is the main.
Do one thing.
main part of this.
Can you reduce your system value otherwise?
Okay, I'll reduce it. Yeah.
Maybe it's coming
Is it
reverse.
okay now?
Hello?
Is it okay now?
Samir?
Yeah, I
Is
think.
it okay? Are you?
Yeah, I think now it's okay.
Okay. Fine. So next in the course we'll also talk about Camel in a big way because Camel is the core of CSV. So Camel is integration framework. It is providing you ability to integrate with the real-time entities. And why we need Camel is normally if you have to do before discussing that, normally what happens, there will be multiple systems within a company also, or your application will be interacting with the application from different companies. So there will be some sort of requirement where the data which is flowing into the system will not be in the same format. Or even if it is in the same format like XML, then there will be differences between the XML data. So at any point of time, we'll hit this difficulty where we have to do integration of multiple systems where data model is different. So we can use multiple solutions. ESB is one of them. You can also decide that if you are system A and you are interacting with system B, you can decide that between A and B, I'll write a application which will convert a model of A into model of B, and when I get a response from B, I'll convert the model of B to A. So you can write a custom solution which will work between A and B. But at a later point of time, when you get another integration between system B and C or system A and C, then again you have to replicate the same thing in some different manner. You have to do customization one more time. So point-to-point solution helps in the short term, but point-to-point solution doesn't help in the long term because of the maintenance issue, because of the if there's any change in the data model, again you have to rewrite the whole thing. So Camel is very useful in such scenarios because it gives you flexibility that you can write the routes and configure them later also based on properties. You can you don't have to worry about the real world entities like system A is exposing web services, but system B is can only receive messages on JMS. All those things are taken care by Camel by providing the components through which you can communicate all this information between two systems. You don't have to worry about writing a web service project separately to handle project A and then writing another JMS project to handle B. You can use the components provided by Camel to do the integration. So if the Camel provides you components using which you can connect to real world entities, and then you can concentrate on the business logic. What exactly you want to do when you get the data from A or when you get the data from B. That logic you can write and you can make it configurable using help of external property files and other things. So Camel is like gives you kind of shortcut where you can use and configure them and then do the integration rather than writing the whole business logic together. So how Camel does it? Because Camel has support for a lot of components. Like 150 plus components are available in Camel, which you can use for integrating the two systems. Most of the common components that we come across integration is web services, database, web services, both REST and SOAP services, database, files, brokers, messaging brokers, FTP, and others. So these are the most common integration points. So, and apart from supporting a long list of components, Camel also has support for very good data transformation model. So suppose that you are getting an XML of one version from one system and that other system needs another version. If you have to develop a normal Java application, you may be writing some parsers to convert that, or you may be writing some XSLT application to do that. But in Camel, there is a component for XSLT. You can just call that component and give the right XSLT and it will do the conversion. Apart from doing the XSLT, it has support for many other methods for data transformation. You can change the data format, you can change the data type. We can use Java code to do that. We can use Camel components to do that. We can use Camel features like Camel has support for some good data formats like JAXB or Extreme or JSON. So we can use those default data formats to do the conversion. So a lot of supports are there in terms of data formatting and transformation to do the integration. And you can use most of the time we do plugins. We use them as a plugin in our integration logic. Then Camel also has support for very good error handling. We can in the integration, errors are like one big problem because you don't know how the other system will behave many times. And then if you know that this is the data coming, you can write some code accordingly. But if some unexpected thing comes, Camel has a very good error handling support. We can decide if I want to handle that exception or not, or if I just want to throw it back. So if you want to handle the exception, there are also methods how to create how to handle that exception and then send a nice response back to the customer. There is also provision to do redelivery of the messages because most of the time when we talk about integration, we'll be talking about some network resources like database, brokers, file locations, web services. They may not be available all the time. There is a downtime for every system. So if you have a failure, if you send a message during that failure window, the message will fail. But Camel has a very good support for redelivery. You can define the redelivery policies, and then the message will go after some time when the system is available. And based on this redelivery, you can take some decisions how to handle the failure message. We can write some routes to take care of those kind of scenarios. So a lot of things are there. Database support is there. We can use normal JDBC. We can use some components for SQL database. It has support for JPA. It even has support for the Hibernate component, but Hibernate is an extra component that you have to manage the license and then you can use it Camel. Camel also has a lot of integration enterprise patterns, which is the attraction of Camel. So there are many things that we do in the real life, and it happens in a pattern. Like you may have a requirement to get some record from database and then split the database on some condition, and then send one by one to some processing. So if you have to do that in a normal application, you'll be getting the record sets and then going over all the record set, getting some data out of it and sending for validation. But here we have a pattern called a split. You can just pass the data to the splitter pattern, and then you can tell how to split it based on what condition or based on your own custom logic. It will split and do the processing. Similarly, you may get data from 10 sources, and then you have to consolidate all of them and create a response. So we have aggregate pattern. So a lot of enterprise AIP, enterprise integration patterns are there, which we can use in our Camel routes and then do the integration. So that makes it we don't have to write those code again because they're already available by Camel. Now, how do we write our routes in Camel? So Camel provides you multiple options to write the routes. So routes are the integration logic. We call them route, and these are the integration logic through which your integration will work. So you suppose that, for example, you have a problem like you need to read from a file and send to a JMS queue. So your two entities you are connecting. First, you are reading from a file location. Second, you are sending to a JMS location. For connecting these two, you don't have to write any file interface or you don't have to write any JMS interface. Components are available from Camel, which we can use. So, and then once you get data from file, the integration logic will start. You have to, based on the requirement, you have to see what you have to do with the data. Do you need to validate the data first, or do you have to transform the data into another format and then send it to broker, message broker? So we will be concentrating more on the business logic. We will be using the components to get the data, doing some integration using the route, and then sending it to the broker endpoint. So that part we will be seeing. It's just an example, but we will be seeing more this kind of routing. So routes we can write in multiple ways. So you can, if you
are you sharing anything? I cannot see anything.
I'm not sharing the route anything. Can you see a notepad here open here?
Yeah, I can see it now. Okay.
So I'm not sharing anything on the route. I'm just talking about it.
Okay.
Yeah, if you want, I will share something. So you can write your routes in multiple ways. First is, if you are familiar with Spring, you can write your routes in Spring. Spring is in right now is the most popular way of writing the Camel routes because people have a good background in Java, they know Spring, and they can write routes in Spring. Camel also provides the option to write the routes in Java DSL. So if you want to write the routes in Java, not exactly Java, but Java looking language. You can write in Spring DSL. Camel also provides the option to write routes in another scripting language called Ruby. If you have a very good background in Ruby scripting, you can write your routes in Ruby also. You can also write your routes in Blueprint, which is another form of XML and optimized for OSGI. So multiple ways are there. There could be many more, but I'm at least aware of these four. So we can write the routes in Spring, in Ruby, Java, and Blueprint. So during the example, most of the time we'll be writing our routes in Spring, but we'll also see some examples in Java and some examples in Blueprint, so that you are familiar with all the at least three route writing mechanisms. There is since there are multiple ways of writing routes. Performance-wise, there is no such report that says which route is good, which route is. If you're writing in Spring, it is better than writing in Java. There is no such thing. Performance-wise, they are almost on the same line. Okay. How do you run those routes? So running those routes means we need to create a small application, and that application, inside that application, we write our routes, either in any other language like Spring or Java or Blueprint or any other. After writing the routes, we need to bundle that application, or we need to build that application, and then we can deploy that in Fuse. So Camel is using Maven. Maven is used for defining the dependencies of your project, and it is used for building the project. So I hope most of you have worked in Java, so you are aware of Maven, how it works and all, right? Are you guys aware of Maven? How to use it? How to build it using Maven?
Yeah, I'm aware of it.
Okay. So using Maven, we can build our application, and then we can deploy in Fuse. So how do we deploy? There are multiple ways to deploy that application also. So for testing purpose, normally people do hard deployment. So you take the application and put it into a folder of Fuse, and it will be hard deployed, and you can test something. So during our classes, for testing the routes and all, we do the hard deployment and we test it out. But hard deployment, many people don't prefer in production environment. So Fuse provides a deployment model through which we can define the how I want to run my application in Fuse. So in the deployment descriptor file, we define what are my application properties, what are my application dependencies, and what are my application jars. And those jars will be deployed in Fuse. So you will not be doing hard deployment. It is called feature deployment. So you will be deploying a feature. So as I said, SGI is used for internal deployment. When you build the application, you will get a jar file, and that jar will contain the classes, Java classes that you are going to use, and the jar can contain the routes also. So that jar is not a normal Java jar. So that jar is called a bundle. It is a OSGI jar, a plant jar, and it is called a bundle. So this bundle, what is the difference between a normal jar and OSGI jar? That in the jar file, you'll find a manifest file. If you have opened a jar file, you'll find that there will be a meta.inf folder. Inside that, there will be a manifest file. If you open it. So if you open, let's say this is a normal, let's say this is a jar file. So inside the jar file, you will come across a meta.inf file, and inside that you will find a manifest file. So if you have a normal jar, in some jars you will find this meta.inf file, some jars you may not find it. But in the OSGI jar, you will always find this meta.inf file. So if I open this meta.inf file, what is the content of this? Can you see it this way? So here you will see some manifest information like what is the when it was built, what is the JDK version, who built it, what is the manifest version, what is the name of this jar, what is the symbolic name, what is the version, how it was created. So these are the basic information about this jar. And then you will see export, then you will see another section called export package and import package. So in, as I said, OSGI is a modular concept where you have to declare your dependencies and you have to also expose your services. So when you declare the dependencies, it is done through the import package. So using the import package, we tell that I need these many packages for running my application. So I need javax.persistence, javax.xml.bind.annotation, I need org.apache.camel, I need org.apache.camel.processor.aggregate. So these are the packages I need. Similarly, these are my application dependencies, and these dependencies you don't have to hand code. They come from the POM dependencies. So using POM, these dependencies are auto-populated, and this dependency comes from the imports that we write in our Java code. Okay. But this doesn't include any Java core dependencies like Java main Java dependencies. Any external dependencies or anything will be coming here. What you are using as an import into Java class or the routes. Then export dependencies are the features or the packages that I am giving to others. You may not give, it's not a mandatory one. You may not expose any service, that is fine. But you always have some import. So using the import, you are telling that for running this application, these many packages should be available in the runtime. So normally what happens if you have a traditional way of deploying application, let's say I have to deploy something in Tomcat, then what happens? I will be creating a WAR file. In that WAR file, I will have my application jars, and I will also have other jars, like if I am connecting to database, I need some Microsoft SQL Server jar, or if I have I'm using some common IOs or common file or some packages from common, then I need to bundle all those, keep all those things together. And so one application will be a WAR file in Tomcat. Inside that WAR file, there will be all the dependencies that you need. So you will be clubbing everything together and deploying in Tomcat. So if suppose that I have one application like that, similarly if you have another application like that, you will also bundle some jars and put in the WAR file and deploy in Tomcat. So there could be a high possibility that I can also bundle some jars which you are also bundling.
Pawan, can you be a little bit slow? Actually, we will not able to follow you. Okay.
Okay, sure.
Yeah.
Yeah. Thanks for letting me know. So what I was saying is, when we deploy any application, we need to provide all the dependencies also, correct?
Yeah.
For example, you take Tomcat. So if you take Tomcat, how you deploy the application? You create a WAR file. Inside the WAR file, you will have your application jars. Plus, you will also put some extra jars, dependencies of your application, right? And then you create a big WAR file and you deploy that in Tomcat. What will happen in deployment? It will try to deploy your jars, and it will look that this jar is using another these classes are using another packages. So it will look into the jars, wars in the jar which are there in your war, and then it will try to find all the classes and deploy it. Suppose that is one application. There is another application from me that also use some of the common jars which you are also using. But I am also putting them in a WAR file, and you are also putting them in a different WAR file. It means we are duplicating the classes, right? In case of Fuse, since we are using OSGI, if you deploy your application, you don't have to carry any dependency jar with you. Suppose that you need the javax.persistence package. So that is coming from, let's say, abc.jar. You don't have to carry this jar with you. You just say that I need a javax.persistence package.
Okay.
Okay. And Fuse will resolve this dependency on your behalf. Fuse has a library. In the library, it has all the possible jars, and it will use that library to give you this package.
So where do you specify these dependencies?
Yeah. So for that we have to look into a project and we have to say these dependencies are defined in the POM file of the project.
Okay, so maven pom.xml you are saying?
Yes.
Okay.
So based on the dependency you provide in the maven pom.xml and the classes that you import in your code, right? We have import statement.
Hmm.
Based on this list will be populated.
Okay. So how does the Fuse knows like from which repository it has to take those jar files?
Yes. So when we do the installation and configuration of Fuse, we'll go through this part.
Okay.
Basically, Fuse has a repository in. So if you download Fuse from Red Hat site, it will be like 700 MB or 500 MB jar file. Okay. And inside that there will be a system folder where all the jars are available offline.
Okay.
And inside there will be like thousands of jar, I believe, and one of the jar will provide this dependency.
Okay.
What they have done basically is, since it is ESB, they have to provide all the possible options. So they have bundled all possible jars that we need for integration support. Okay. So that load itself will be like some 200 MB, 200, 300 MB of dependency they will be providing. It will cover a lot of thousands of jar, and I don't think that we'll need anything apart from that. So it will have all the libraries, mostly used libraries in Camel.
So Fuse has its own repository then?
Yes, Fuse use multiple options to do the deployment, resolution of these dependencies. First, it will check that it can deploy this dependency from its local repository. First of all, it will check. Okay. If it is able to, 99% of the time, it will be able to fix the dependency from the local repository because they have already bundled it. Let's say for 1% of chance it is not able to find a dependency locally, then Fuse also provides a list of Maven repositories in the configuration file.
Okay.
We have some Maven Nexus repositories, right? We have some Spring repositories.
Yeah.
We have some other well-known repositories. So Maven has a list of all those repositories with it. Okay?
Okay.
And those repositories are well-known repositories, so their URL will not change.
Okay.
In most of the cases. Okay?
Okay.
So first it will check locally. If it is not available locally, then it will go to the URL. It will try to connect to internet and download those dependencies. Okay. Suppose that when you deploy the Fuse in a system where internet is not available, or it is available but is not given for this particular user who is running Fuse, because in a production environment you don't want your server to connect to internet and download something, right? So you can also, in many companies, and not many companies, most of the companies, they have some internal repository, Maven repository for the company, right? So you can also give the path of your internal company Maven repository. From there, Fuse can go and download it.
Okay.
Okay. So three options are there. First, it will resolve in the local repository. If it is not able to resolve in the local repository, it will go through the list of all the Maven repository which is configured. Either it will try to get it from your company Maven site, or it will try to connect to internet and download it. If all three fails, then it will give a error that it cannot deploy this application because of the dependency issue.
Okay. So the output file of the Fuse project, for a Tomcat, we using a WAR file, right? So it will be like .osga.
No. It will be. I'll show you. Let me just open.
Yeah. Okay.
So basically, how we do the deployment is, whenever we create, what we need to do is we need to create a Maven project. Okay. In the Maven project, you will have a type of project, correct? So normally in the Maven project there is a type. By default, that type is jar. So when you build the project, you will get a jar file. Or if you say war, then you will get a war file, right? That's how Maven works. You give the type of artifact, and it will build in that way. So if you give a jar file, then it will create a jar. If you give a war file, it will create a war. In case of OSGI, we will say the type of artifact is bundle. Okay. So when you say the type of artifact is bundle, then it will create a jar file which is compliant to OSGI.
Mm-hmm.
Okay. Then it will create a jar file with this kind of manifest.
Yeah, yeah.
Automatically it will create, and then it will populate all the dependencies what you need. Also, if you want to expose any service, then it will also expose this export package. It means, what is the meaning of export packages? I am creating an application which is export package like com.test.common.
Mm-hmm.
What does this mean is, from my, let's say this jar is called abc.jar. From my abc.jar, I am exposing a package called com.test.common. It may contain four or five utility classes that you can import and use in your project.
Mm-hmm.
Got it, right?
Mm-hmm.
So I am creating a jar called abc.jar, and you want to use some of the APIs from my jar. Okay.
Mm-hmm.
So in your Maven project, you will give a dependency of ABC jar, right? How we use the dependencies.
Yeah.
Then how you use those packages is, if it is a OSGI, you can only use the packages if you say, if I export them as services and you import them as dependency. So in my jar, I will explain. In my jar, I'll have an export statement like this, export package. Okay.
Okay.
So I will say com.test.common is my export.
Mm-hmm.
So once I say it is my export, it will be registered with OSGI as a API.
Okay.
So OSGI has a registry where it will say com.test.common is available for anyone to use.
It's like a utility kind of thing, you're saying?
Yeah. It's like a utility which I'm exposing for other people to use. In your project, let me open. In your project, form.xml file, you will have a dependency. So normally how we do it? So suppose that this is your project form. So you will have a dependency. So inside the dependency, you will say group ID, group, and then you will say artifact, and then you will have a version.
Can we move on rather than sticking to the dependency, because we have a lot of topics to cover? This is just a demo, right?
Yeah.
Please.
Fine. Okay. So we'll see these things in detail. So you don't worry. We'll see these things in detail. So we'll see the dependency resolution and others. Okay. Next thing is then once you deploy the routes, you can deploy them hot deployment that we will see, and you can also do through the feature deployment, and we'll also see during that class. And once the routes are running, and once the data come to the route, you will be getting your integration logic will be triggered, and it will do the integration as per the code or route you have written. Okay.
So can we cover web services development with Fuse also, like SOAP and REST-based web services?
Yeah. So So if you have seen the syllabus that what I've shared with you, you will see we'll be covering enterprise patterns, we'll be covering the components, we'll covering web services, we'll cover some database, we'll cover JMS, we'll cover error handling, we'll cover some debugging, troubleshooting, and unit testing. Plus a lot of EIP patterns. So we'll cover all those things. We'll see SOAP web services, RESTful services. SOAP will see both the contract first and code first approach. And RESTful will see through multiple ways. Camel provides support for multiple ways to do the RESTful services. You can use Apache CXF, you can use some of the components from Camel. So we'll see both approaches. In SOAP also we'll see code first approach and the contract first approach. Okay.
Okay. So one question, like, what makes like Fuse ESP more efficient than Mule and other ESPs?
I have not done that comparison, but
No, no, I mean
lot
just
of
I'm just asking
yeah.
for my knowledge purpose actually, because I worked on a mule, so I just want to know like what will distinguish more value to the fuse. So that's why.
See, Camel, one difference I see is I'm not sure what Mule is using for routing and validation, but Fuse is using Camel, which has a very wide support. People
Mm-hmm.
are using Camel with or without ESP, and Camel is there for 10 plus years now. And it is very strong in routing and validation, and it has a very strong community that is supporting it. There are a lot of big people who are running Camel, and they are like supporting it, developing it, and providing support to the other people who are using Camel. So it has very growing and active community where you can find solutions to your problem, and you can collaborate with other people. So that is one advantage of Camel. I have used Camel without Fuse also. Like I'm using
Yeah.
Camel from 2008 on 2007, 8 onwards actually. And at the time there was no Fuse, or there was no ESP which was using Camel. We were using as an independent application runtime. Uh, Later we started using Camel with Tomcat, and now we are using Camel with ESP from last 3 years.
Mm-hmm.
So Camel is like always you will find a lot of components, a lot of data formats, a lot of EIP patterns. You can readily use them and write your routes in a very quick time. So we have like a 3 week cycle. Every 3 weeks we do some integration, and you can like reduce a lot of time. That's one advantage I see with Camel.
Yeah, I mean, using Camel, we have many advantages. Like, I mean, as you said, like we can use Camel with other ESPs also, right? So, what makes Fuse more efficient?
See, what makes Fuse more efficient is it has bundled a lot of open source stack together and taken
Okay.
care of all those dependency management. So you don't have to worry about okay how do I need to connect to a broker? It already gives you a broker. You can use that embedded broker and do the integration. It
Actually,
already gives you.
I can answer that question in a better fashion.
Okay.
Apache Camel is free, totally free.
Yeah.
If you have continuous integration, continuous delivery, inversion of dependency injection, all this stuff, Apache and Apache Maven and Apache Spring and Hibernate framework will help you, and you don't really have to do anything.
Mm-hmm.
But if you go for Fuse, then some of the components are already pre-built, and you have to just buy the support. If you go for WSO2, or nearly 12 components are there, you may have to pay a lot of money. The master ESB is WSO2, but that's not very popular. Then Mule came up a couple of years ago, and Salesforce started supporting them, and they built over 250 connectors. Now they created any point platform, and that itself is a web place where you can just deploy your runtime. And so Mule started picking up the momentum. Now Mule is leading, Altacian is leading, and JFuse is surviving to make marketplace. WSO is the master ESP after Oracle service-oriented architecture and microservices. WSO2 is the master one, but JFuse, and there are other 3 of the Maltesian, and Apache has other routers also. Camel is basically a router. And then it has other components like he was mentioning earlier. There are framework support, there are ActiveMQ, there are other components that you have to manage. And especially if you go with Fuse, you go with Apache Camel, you have to manage at least 5 or 6 components for different actions and different integrations. If you go with the Mule, you only have to manage the Anypoint Studio as well as the runtime, and that's it. And the Anypoint platform give you everything. It gives you an API manager, it gives you the runtime manager, it gives you support for RAML, it gives you everything. But if you are coming with the JFuse or Apache or Ant or any other tool, then you are looking at working on different 6 technologies. The technology is now driving to the RESTful web applications, whereas most of this technology is not up to the RESTful. It is still going for SOAP, which is completely dependent on XML and XLD. So That is the difference between Apache, JFuse, and Mule, and any other ESPs.
Okay.
By the way, I work as a Mule architect.
Oh, okay.
Okay.
You're talking like Bob?
Yeah, I'm a Mule architect. Yeah.
Oh, okay. Yeah. Thanks.
Yep.
Yeah.
So I can get more details.
Yeah.
Right. So yeah, so JBoss Fuse is basically, as you said, it's open source and it has actively built on Camel, which has support for which is there in the integration world for a long time, and people are using Camel without any ESP also, and they are doing it very well. So you can count on the Camel capabilities more than Fuse, the Red Hat capabilities. So Camel is main here for doing the integration. And what the value Fuse adds is on top of Camel is it gives you a console where you can see messages, you can do live debugging, you can manage your application. So there's an administration console. Once you deploy Fuse, we'll see it where you can manage some of the aspect, administration aspect, and server aspect of it. So we'll see that during the installation configuration part. Yeah.
And one more question, Pawan. Like we can write the routes in two different, right? Like Blueprint and Spring. So I think both are based on like XML configuration mechanism. So which one will be good actually? I mean, because I see the syntax will be similar for both. So just ask.
Yes. So yes, more like you can decide that. See, what is the difference between Spring and Blueprint is. Spring can run in OSGI and non-OSGI both the servers. Okay. If you write your routes today in Spring, you can deploy in JBoss Fuse. With minimal changes, you can deploy in Tomcat also. Okay.
Okay.
But if you write your routes in Blueprint, it can run only in OSGI server. It is kind of optimized for OSGI environment. You cannot run a Blueprint route in, go back and run it in Tomcat. That's the one disadvantage.
Okay, so generally which approach we'll take? So either Blueprint or Spring?
It depends on if everybody in your team is okay for Blueprint, you will use Blueprint, but most of the examples I have will share in Spring, but I will also walk you through some examples in Blueprint and one example in Java DSL also, so that at least you are familiar with all of them.
Okay.
But since people are using Spring for a long time from other applications, they find it more convenient in Spring. But there's no restriction as such. You should be writing only in Spring.
Okay, yeah.
When I started writing Camel routes. I used to write in Groovy scripting language. And I will be writing a file like route builder or something. I'll be writing the routes in a file which will be ending with .groovy extension. And when I build that file, it will create a .class file. So then the 2-3 people who were working in Groovy, so everybody started in Groovy. Then later more people joined, they were not familiar with Groovy. So then we said, okay, we'll use Java DSL. Then people started writing in Java DSL. We stopped writing in Groovy and we migrated all the way to Java DSL. And then there were some people who joined from other teams, and they were more familiar with these Spring integrations. So then we said, okay, for convenience of everybody, let's write in Spring. Then we write all our routes are getting written in Spring. Till the time we were deploying in Progress Fuse. Now when the JBoss Fuse came, it has a OSGI support, and people did some analysis that OSGI Blueprint is more optimized. Means optimized in the sense Blueprint exposes some services for administration purpose. OSGI exposes some services like for administration purpose, configuration purpose. So those services you can easily access in Blueprint because it is written on top of OSGI. For Spring, you may have to write extra configuration line and then access them. But the Blueprint, you can directly use them. So that is the optimization in Blueprint compared to Spring. You can use them in Spring also, but only thing you have to write an extra configuration line to access them. That's the difference.
Okay. Yeah. Thanks, John. Thanks, sir.
And once we are talking about the details, we'll also see what is the data model that gets that is used in Camel. Like this is not a data model talking about the XML or CSV or object. This is the internal model that is called exchange. The data which is transferred from one part of the route to another part of the route. What is the structure of that exchange? Where we get the incoming data, where we get the outgoing data, what are the message headers, what are the attachments, what are the structure of the message, all those things we'll discuss. So, and what are the flows, type of flows. So, you can get a data which is only incoming, or you can have a data which is both incoming and outgoing. So, there are different patterns of the message. So, we'll see, go through all those patterns also so that we can write the routes accordingly.
And also, like, how we can like handle exception handling in Fuse?
The Fuse provides a very robust exception handling mechanism. You can decide to handle the exception, or you just throw it back to the customer. There are a lot of approach and principles. We'll go through it.
Okay.
So apart from exception handling, they also have a concept called error handler.
Okay.
So which is a concept on top of exception handling. So we'll see that. And there is a very good hierarchy of exceptions and errors. When it will go for exception, when it will go for errors, all those things are very well defined. So we can leverage that model and we can build our application.
Okay.
If you have any other question? From my part, once we go through the example, we go through the some theory part first, and then we go through the route, how to write that in a configuration. We'll also try to do execution of the route, and I'll be giving you some. I'll be sharing the samples with you so that you can build on top of it. Plus, I'll be also sharing some notes or some pointer in the routes itself so that you can do some further study also. Okay.
So you'll be sharing us handouts also, like I mean, soft copy of the notes also.
Yeah.
Okay. And example code also, like what you are using through show us the demo.
Yeah, I'll be sharing the samples, classes, sample classes or sample routes or any other node which is required.
Okay.
Okay.
Yeah.
Okay, thanks for joining and listening to me. It's a long session, but appreciate your patience. If you have no other doubts or questions, concerns, I think I'm good from my end. The other logistics you can discuss with Shiva, like timing and other things. And then once you guys are okay, we can start.
How many days are the class?
So normally, going with a normal pace, it will take around 20 to 25 classes maximum to cover all the topics.
So in
And one class
25,
will be like, yeah, 25 days. Yeah.
25 days means 25 hours, right?
Normally I say 1 hour, but during the discussion it really it goes to 1.5 hour, 1 hour 15 minutes, 20 minutes like that.
All the components.
So 25 classes. Sorry.
All the component installation and setting up will at least take 5 days, 5 hours at least. All the components, everything will be getting up and running.
Yeah.
So I don't think we'll be able to finish everything in the components that you said. I don't really want an overview. I wanted to be able to create an orchestration or create a flow or something like that and try to connect end to end. Say, for example, if there is a web application coming, then I want to get the JSON data and I want to convert this into JSON. maybe put it into a PostgreSQL or some JSON supported database, and I want to be able to process that. Number one. Number two, if we have a file, then we want to maybe put it in a database or consume by other applications, and in the meantime, combine the files, modify the files, edit the files, delete the files, and add value to the files, and also transform the file contents. That's the other thing. Third is that we want to collect scatter gather or some, we want to collect multiple inputs from multiple sources, then put together into one routing, one place where we can combine this together and make available for other applications to consume, either in XML format or Java list or any other format. So once we do this multiple iteration of this, it will probably take at least 20 to 30 classes. That's what my assumption is. I don't really know, and also I don't really know the style of the class and what you cover, how fast things are. I don't really know. So this was just a thought that I want to run by.
So whatever you mentioned will cover all of them. There may not be a very continuous thing that you start with one approach and then you keep on weaving on top of it. But all examples are like interconnected, and we'll be going through one concept or one pattern at a time, and we'll be discussing all the aspects of it. And then you can use that knowledge to build on top of it. If you're working on any application, you can apply that in the application.
Okay, all right. Yeah, that's all. Thank you, sir. And what do you deliver as part of the course? Do you have any documentations, any examples, or any scripts, any codes, or what?
Yeah. So I'll be sharing some notes on some of the theory part. I'll be sharing some examples. All like whatever classes we'll go through, I'll be sharing the examples. Those sample routes, end-to-end sample routes with the sample Java code, and working sample routes.
Okay.
And any useful link I come across, I like during this process of training, I have gathered a lot of useful links which can help you in your real-time integration. All those things I will share with you.
Okay. The
record you will also get it the meeting, I believe. Shiva will be sharing that with you. Yeah. So that you can read a bit.
Yeah. Will you make the recordings available to us?
Shiva will, I guess, he will answer this question. Recordings will be shared with them, right, Shiva?
Yes.
Now, what mode is that? Downloadable or viewable at a website?
Both we can do. Download means it will take for you. Not a problem. Okay.
No, I didn't understand. Downloadable means what?
Download means it will take a lot of time for you. If you want to view, you can do view also, or else if you want to download also, I can give you. But it's up to you.
Okay.
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 Right. Thank you.
Bye. Have a nice day.
Samir?
Yeah, thank you. Yeah, thank you.